talk about trapezoids. So here's a picture of a trapezoid. We just learned about quadrilaterals, so you should be familiar with all these pieces of them. We've got our two bases, the parallel sides, and then the two legs, which are the non-parallel sides. And I know that you've been doing the area of a trapezoid for forever. Here is kind of where the formula comes from. If you put one trapezoid and kind of twist it and put it next to the other one, or flip it over and put it next to the other one, you end up with, in this picture, what looks like a parallelogram here. And so the shape of the base, if you put these B1 and B2 together, and then we've got our height of h, and then our area is base 1 plus base 2 times the height. But here we have two of them, so we're going to divide that by 2. Also, the height has to be perpendicular to the base. So that's just kind of like a brief review of that formula. So here I have a trapezoid. It happens to be an isosceles trapezoid, and the question's asking about the perimeter of this isosceles trapezoid. So if we know that it's isosceles, we can drop in both of these heights. And being isosceles, we will know that each of these little right triangles on the sides are going to be matching. And so this bottom part here would be 5. Also, if this is 10 here, this is 10, and so that's 10, meaning that the whole bottom of it ends up being 20. And we can do Pythagorean theorem in this right triangle right here to come up with the hypotenuse. It is also a Pythagorean triple. And so if you know your triples, you might recognize 5, 12, 13 as a Pythagorean triple. But again, you can do a squared plus b squared equals c squared and then square root and get 13. And since it's isosceles, this will also be the same. And then for the perimeter, you're just going to add up all the sides of your trapezoid here, and you end up getting 56. And they did not have like inches or anything on here, so I'm just gonna, since I want to be sure that I get in the habit of writing all my units, I'm going to write 56 units for the answer. The next one says that a baseball diamond is 90 feet on each side. Find the distance from third base to first base. Well, if you have a baseball diamond, it's kind of like having a square that's just twisted. And so what we have in this baseball diamond, and this is a terrible picture probably, but we have this square baseball diamond here, and they want to know the distance from third to first base, which would go from here to here. And they told us that it's 90 feet on each side, so each of these is 90 feet. And so this diagonal here will split this to 45 degrees and 45 degrees, and so we have a 45, 45, 90 triangle going on, which the rule was x, x, x root 2 for that. And so the 90s are our two sides that are our x's, and so the one that's across from the right angle is going to be 90 root 2 right there. You could also do Pythagorean theorem and get there and do simplest radical form that way as well, but the distance is 90 root 2 feet. Because we do want to have radical form whenever possible and not do any rounding. The next one says, what's the altitude of the trapezoid to the right? And so I'm going to draw two altitudes. I'm noticing that this trapezoid is isosceles because of the 25s on the legs. So that kind of helps us set this up. So we've got a couple of right triangles, and if this is 25 across, then this part here is 25 as well. And 35 minus 25 is 10, and since this is isosceles, each of these pieces is going to be equal, so they will be 5 and 5. And so we have 5 on one side and 25 on the hypotenuse here, so 5 squared plus the height that we're finding squared equals 25 squared, so just Pythagorean theorem right there. And when you solve it, you get the height squared is 600, and then you're going to square root that. And you get 10 root 6 when you simplify that radical for the height. And they did not have any specific units, so I'm going to put 10 root 6 units for the height. which is the altitude, same thing, and we're done with that one. The next one at the bottom, kind of a weird picture, just really 3 right triangles together. Lots of Pythagorean theorem is all we're going to do. I do see a triple here. I've got 12 and 13, so this piece will be 5. Right here, 12 and 15, that is coming from the 3, 4, 5 triple. This is 4 times 3, this is 5 times 3, so this will be 3 times 3, and it will be 9 right there. Of course, you can do Pythagorean theorem, find the missing pieces. If you do Pythagorean theorem on this one, and it also is a triple, Pythagorean theorem gets you 17 for that distance, and so the piece that's 17 is made up of 5 plus 9 plus x, and so 17 minus 9 and minus 5 will leave you with x, which is 3 units. Next, we have area formula of a rhombus and a kite. The area of a rhombus is 1/2 diagonal 1 times diagonal 2, and it's the same for the kite, 1/2 diagonal 1 times diagonal 2. Here we have a problem. It's telling us that we have an isosceles trapezoid, which means that the 2 legs are congruent, and it's a fence around an area, and we want to find the exact and approximate area. Exact and approximate. So approximates are decimal, exact is radical form, or if it's a whole number, then it answers both. That's enclosed by this fence, and we also want to find the exact and approximate perimeter of the fence. So we've got lots to do here. First thing though, we got to draw the picture, and it's kind of hard to think about drawing this one. I found kind of difficult. So AB is 16 and CD is 8. Since it's an isosceles trapezoid, these are obviously the bases. So we have one base of 16 and one base of 8. And it's an isosceles trapezoid. And I guess I put AB on top because it came first, but you certainly don't have to draw it looking like this. So here's AB, that's 16 feet, and CD, AB, this will have to be CD, like that, 8 feet. Because when you name it, you have to go around A, B, C, D, like that. And then they have, this should be an angle symbol. Measure of angle A is 60 degrees. Okay, so it's an isosceles trapezoid, which means that we can drop in the heights. So here's one height, and here's one height, and we're going to need them because we need to find the area anyways. And so if this is 8 across here, then this part is 8. And then when you do 16 minus 8, you're left with 8, which means divided by 2 is 4 here and 4 here. And so I'm noticing that they gave me this 60-degree angle, and it's a right triangle here, so I've got a 30, 60, 90 triangle. And so I'm going to use that 30, 60, 90 rule from way back. So x root 3, and 2x here. And so the 60 is here, which means that 30 would be here, and the 4 is across from the 30. So the 4, put that under the 30. 4 is my x, which means that 60 will be 4 root 3, and then go back to the 4 again, double that for the 90, so the 90 is 8. So across from the 90 is an 8, across from the 60 is a 4 root 3. And then this being an isosceles, this will also be 8 over here. We'll need that for perimeter. So for the area of this trapezoid, it's the 2 bases added up, which is 16 and 8. And it's 1/2 of that, so you can put this 1/2 there. 1/2 the sum of the bases times the height, which is 4 root 3. And so what we'll do is 1/2 of, well, I'm going to do 16 plus 8 divided by 2 times 4 will give you the area. Don't forget to put the root 3 on it because we're not actually putting the root 3 into the calculator. So again, 16 plus 8 divided by 2 times 4 is what I'm doing to get the 48, and then put the root 3 on there because we didn't actually put that into the calculator. And so it's feet squared. This is the exact answer, and if they want an approximate answer, you're just going to do 48 root 3 in the calculator. approximate, they like to use those squiggles a lot of the time. And that is 83.14 feet squared. They didn't tell me where to round, so I usually do 2 decimal places. That's our approximate area. And then the other thing they asked for was the perimeter. And it said exact and approximate, but the perimeter is actually going to be a whole number. So if we just go around the sides, 8 and 8 and 16 and 8, will give us the perimeter, which ends up being 40 feet. Okay. The next one is the area of a rhombus. The area of a rhombus is 1/2 diagonal 1 times diagonal 2. And so this 8 is labeling this top part of this diagonal. So the bottom part being a rhombus, diagonals bisect each other. So this is also 8. And if this is 11, this is also 11. So I have a diagonal that is 16, and I have a diagonal that's 22. And so it's 1/2 times 16 times 22. 1/2 diagonal 1 times diagonal 2 ends up giving me 176 centimeters squared for the area. On the next one, it says one diagonal of a kite is 2 times as long as the other diagonal. So if I have a kite, okay, and we've got one diagonal and the other diagonal, and I didn't want to go through the middle, so I'm just kind of like, there's the length of one and there's the length of the other. One is twice as long as the other. This looks like the longer one. Let's call that 2x. Let's call this x. And they gave us the area, and they want each diagonal. So x times 2x divided by 2, or times 1/2 if you want to go that route, but I like to do diagonal 1 times diagonal 2 divided by 2, equals the area, 56.25. And so x times 2x is 2x squared divided by 2 ends up just being x squared. And then when you square root both sides, you end up getting x at 7.5, which means that one diagonal is 7.5, and this unit was feet, and the other is twice that. So we have 7.5 feet and 15 feet for our diagonals. The next problem, very, very like the one that we just did. If we've got our kite again, essentially it's the same. One diagonal, the other diagonal. One of them's 3 times the other, so this will be 3x, this will be x. X times 3x over 2 equals 73.5. I'm going to multiply both sides by 2 to get this 2 off of the bottom here, and the top simplifies to 3x squared. 2 times 73.5 ends up being 147. Divide both sides by 3. X squared is 49, and then square root. So x ends up being 7, which means that one diagonal is 7, and this was inches, or it was square inches, so the diagonal's inches, and the other diagonal is 3 times that, so it is 21 inches for the second diagonal. And on the last problem, I put a little graph sheet in here, but you could graph it by hand. M is at 1, 3. N is at 4, 5. P is at 7, 3. And Q is at 4, 1. And so what's really nice is that these are the diagonals of the rhombus. There's one, there's the other, and they end up being horizontal and vertical, and so we can just count the length of them. This one is 1, 2, 3, 4 across. So NQ, which is one diagonal, is 4. And MP is the other diagonal, and if you count 1, 2, 3, 4, 5, is 6 across. And so diagonal 1 times diagonal 2 divided by 2, 4 times 6 divided by 2 gives you 12. and this would be units squared because it's area. So there we go, and that's day 1 of our area and perimeter notes.